What if you traveled faster than the speed of light? The world gets weirder the closer you get to the speed of light. When we were kids, we were amazed that Superman could travel faster than a speeding bullet. We could even picture him chasing down a projectile fired from a weapon, his right arm outstretched, his cape rippling behind him. If he traveled at half the bullet speed, the rate at which the bullet moved away from him would halve. If he did indeed travel faster than the bullet, he would overtake it and lead the way. Go Superman. In other words, Superman's aerial antics obeyed Newton's views of space and time, that the positions and motions of objects in space should all be measurable relative to an absolute, non-moving frame of reference. In the early 1900s, scientists held firm to the Newtonian view of the world, and then a German-born mathematician and physicist by the name of Albert Einstein came along and changed everything. In 1905, Einstein published his theory of special relativity, which put forth a startling idea. There is no preferred frame of reference. Everything, even time, is relative. Two important principles underpinning his theory. The first stated that the same laws of physics apply equally in all constantly moving frames of reference. The second said that the speed of light, about 186,000 miles per second, or 300,000 kilometers per second, is constant and independent of the observer's motion or the source of light. According to Einstein, if Superman were to chase a light beam at half the speed of light, the beam would continue to move away from him at exactly the same speed. These concepts seem deceptively simple, but they have some mind-bending implications. One of the biggest is represented by Einstein's famous equation E equals mc squared, where E is energy and m is mass and c is the speed of light. According to this equation, mass and energy are the same physical entity and can be changed into each other. Because of this equivalence, the energy an object has due to its motion will increase its mass. In other words, the faster an object moves, the greater its mass. This only becomes noticeable when an object moves really quickly. If it moves at 10% the speed of light, for example, its mass will only be 0.5% more than normal. But if it moves at 90% of the speed of light, its mass will double. Now, as an object approaches the speed of light, its mass rises precipitously. If an object tries to travel 186 miles per second, its mass becomes infinite, and so does the energy required to move it. For this reason, no normal object can travel as fast or faster than the speed of light. That answers our question, but let's have a little fun and modify the question slightly. Almost as fast as the speed of light. We covered the original question, but what if we tweaked it to say, what if traveling almost as fast as the speed of light? In that case, you would experience some interesting effects. One famous result is something physicists call time dilation, which describes how time runs more slowly for objects moving very rapidly. If you flew on a rocket traveling 90% of light speed, the passage of time for you would be halved. Your watch would advance only 10 minutes, while more than 20 minutes would pass for an earthbound observer. You would also experience some strange visual consequences. One such consequence is called aberration, and it refers to how your entire field of view would shrink down to a tiny tunnel-shaped window out in front of your spacecraft. This happens because photons, those exceedingly tiny packets of light, even photons behind you, appear to come in from the forward direction. And in addition, you would notice an extreme Doppler effect, which could cause light waves from stars in front of you to crowd together, making the objects appear blue. Light waves from stars behind you would spread apart and appear red. And the faster you go, the more extreme this phenomenon becomes, until all visible lights from stars in front of the spacecraft and stars to the rear become completely shifted out of the known visible spectrum, the colors the humans can see. When these stars move out of your perceptible wavelength, they simply appear to fade to black or vanish against the background. Of course, if you want to travel faster than a speeding photon, you'll need more than the same rocket technology we've been using for decades. In a March 2021 paper published in the journal Classical and Quantum Gravity, astrophysicist Eric Lenz of the University of Göttingen in Germany proposed the idea of rearranging spacetime to create a warp bubble inside which a spacecraft might be able to travel at faster than light speeds. Warp. Now, speed of light facts. Is there anything faster than the speed of light? No, there isn't. As an object approaches the speed of light, its mass rises steeply, so much so that the object's mass becomes infinite, and so does the energy required to make it move. And since such a case remains impossible, no known object can travel as fast or faster than the speed of light. How fast is the speed of light in miles? The speed of light in a vacuum is 299,792 kilometers per second, which translates to 186,282 miles per second. Hypothetically, this means that if an object could travel at the speed of light, it could go around the Earth 7.5 times in 1 second. And why is c the speed of light? In Einstein's equation, the speed of light in a vacuum is represented by a lowercase c for constant, or from the Latin term celeritas, which means speed, to the power of 2 squared, that is. And what is the speed of light on Earth? The speed of light can slow depending on what it's traveling through. Light bends when it comes in contact with any matter, even dust, causing slight decrease in speed. And that said, light traveling through Earth's atmosphere moves almost as fast as the speed of light in a vacuum. And this is on Collective Spark. It's by William Harris and Patrick J. Keeger on How Stuff Works. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box.